Good morning, everyone. My name is Anandi, and today I will be presenting on Huffman coding algorithm in data structures using C. This is one of the most efficient lossless data compression algorithm, and we will explore how it works, how to implement it in C, and where it is used in the real world. Here is what we'll cover today. We'll start with an introduction to Huffman coding, then understand prefix codes. I'll explain the algorithm step by step, show its implementation using C language, and go over a real example. We'll also look at its real-world applications, discuss its advantages and limitations, and finish with a brief summary. Huffman encoding is a technique developed by David A. T2. It is a lossless data compression method that assigns variable length binary codes to characters based on their frequencies. More frequent characters get shorter codes, reducing the total size of data. It's the foundation behind many file compression tools. This image visually explains how data compression and decompression works using streams, specifically in the context of compression stream and decompression stream pipeline. Here is a big breakdown of what the diagram shows. The top half, the compression process, the original data stream, which is the input, is the raw uncompressed data flowing into the compression system, represented as blocks in the left box labeled data stream. Compression stream, it reads the original data stream and applies compression. It connects the input data to the compressor logic. Compressor, it is the actual algorithm or module, like Huffman, that compresses the incoming data. It works through the compression stream. The results, which is the compressed data stream, is the output of the compression process. The data on the right is now compressed and takes up less space. Bottom half, which is the decompression process, compressed data stream, which is the input, is the same stream that was the output by the compression process is now the input to decompression. Decompression stream. This stream reads the compressed data and passes it through the decompression logic. It reconstructs the original structure. Decompressor uses the reverse of original algorithm like Huffman decoding to recover the original data. Recovered original data stream, which is the output, you get back the original uncompressed data. This verifies that the process is lossless if implemented correctly. It is the overview. Here is the overview of the data compression and decompression. Prefix code means no code word is a prefix of another. For example, with these assignments, A is 0, B is 10, C is 110, and D is 1111. You can see no code is a prefix of another. This is what makes decoding unambiguous and fast. This property is crucial for Huffman coding to work properly. On this image represents a Huffman tree, a binary tree used in Huffman coding, a lossless data compression technique. Let's break it down clearly and simply. What you are seeing is this tree is used to assign binary codes to characters A, B, C, D, and E based on their frequency of occurrence in the data stream. The codes are prefix free, meaning no code is a prefix of another. The structure of the tree, which is the leaf node, which is the endpoint, is a character with its binary code. Each edge is labeled 0 or 1. Generally, the left branch is assigned 0 and the right branch is assigned 1. To find the binary code for a character, trace the paths from the root to the leaf. For example, for A, if you move left, the path is 0, 0. And for B, if you move left, left, it is 0, 1, 0. That is how representation works. Here is another example of it. Huffman coding algorithm. The step-by-step process. The first step is frequency calculation. Determine the frequency of each word in the input data which is given. For example, A, B, C, D. Second step is priority queue creation. Create a mini heap, which is the priority key where each node contains a character and its frequency. Third step is the tree construction. remove two nodes with lower frequency, and create a new internal node with its two nodes as children and frequency equal to the sum of their frequencies. Insert the new node back into the min heap. Repeat until only one node remains, the root of the Huffman tree. Fourth is the code assignment. Traverse the Huffman tree to assign binary codes to each. Now count the frequency of each character. Insert each character into a mini heap and based on the frequency. Combine the two lowest frequency nodes into a new node. Repeat this process until there is only one node left, the Huffman tree. Then assign the binary code by traversing the tree. Left is 0 and right. This process ensures shorter codes for frequent characters. Now this shows step-by-step building. This image shows a Huffman tree, which is the core structure used in Huffman coding. Let's break down the image step by step to understand its significance and how it works. What is a Huffman tree? A Huffman tree is a binary tree used to assign prefix codes to characters based on the frequency of occurrence. The more frequent a character, the shorter is its binary code. The leaf node, this represents the characters and the frequency. F is 45, C is 12, D is 13, A is 5, B is 9, E is 60. The internal nodes. Each internal node shows the sum of frequencies of its two children. These nodes are used to construct the tree but do not represent actual characters. Step-by-step construction uses the bottom-up approach. Start with all characters and their frequencies as leaf nodes. Pick the two smallest frequencies. Combine them into a parent node. A is 5 and B is 9. The new node with frequency 14. Repeat the process. 14 and E is 16. New node is 13. Again, C is 12 and D is 13, so the new node is 25. Now combine 25 and 30. New node is 55. And finally, F is 45 and 55. The root node is 100. This is the actual construction. Now, the binding configuration. Huffman tree, left edge is 0 and right edge is 1. Traverse from the root to each leaf appending 0 or 1 as you go. Let's derive the binary codes. F move left is 0, C is right left left, which is Huffman code is 100. D is right left right, Huffman code is 101. A is right right left left, according to the binary tree, Huffman code is 1100. B is right right left right, Huffman code is 1101, and E is right 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 111. Moving on to how you can use Huffman coding in C language. In C, we use a struct mini heap node to define each tree node and struct min heap for the priority queue. We then use functions like create node, build min heap, and build Huffman tree. The print codes function does a tree traversal to print out final codes. This helps you understand heaps, trees, and recursion all in one project. Here is a simple breakdown of the code. This code defines a struct in C named min heap node, commonly used in Huffman encoding. Struct min heap node begins the definition of a structure named min heap node. Char data. This stores a character like A, B, etc. In Huffman coding, this is the symbol we are compressing. Unsigned FREQ. This stores a frequency, that is how many times this character appears in the data input. Type unsigned means it can only store non-negative integers. Struct min heap node. Asterisk left, comma asterisk right. These are the pointers to left and right child node used to build a Huffman tree where each node may have children. And parenthesis closes the structure definition. Encoding string. Encoding the string A. Let's take an example. Suppose these are the character frequencies. A is 5, 1, 6, is 3. After building the tree, the Huffman codes are C is 0, A is 1 1, D is 101, B is 100. The original, which is 4 characters into 8 bits, is 32 bits. 4 characters is the number of characters given here, and 8 bits, which is the normal ASCII value used, is 32. So after multiplying the original size, we get is 32 bits. Now the compressed size, since after using Huffman coding, the size becomes the variable length. So the compressed size of C is 6, which is the given frequency, and 0, 1 here is the number of bits, which is 1. A is 5 into 2. 2 here is number of bits, that is 1 and 1 together makes 2 bits. Plus D is 3 into 3, B is 1 is into 3, which adds up to 28 bits, saving 32 minus 28, which is 4 bits. This is a display of the example given. In real world example, Huffman coding isn't just theoretical, it's everywhere. Zip and GZIP use it for file compression. JPEG uses it to compress image data. MP3 module formats uses it to reduce audio video size. This Huffman coding is crucial with computer science and digital media. This makes Huffman coding crucial in both computer science and digital media, and here are some formats. Now, advantages of Huffman coding. Huffman coding has three main strengths. Efficiency. It provides optimal prefix codes. Lossless. No data is lost during compression. Versatility. It works for text, images, and even sound files. Moving on to limitation of Huffman coding. However, it's not perfect. It requires prior knowledge of character frequencies. There's extra storage needed for tree or codebook. It is not ideal for small data sets or data with equal frequency. Moving on to the conclusion. To sum up, Huffman coding is an elegant and powerful algorithm. By leveraging frequencies, it reduces data size without loss. Implementing it in C gives us practical insight into tree and heap. It's widely used in the software you use every day, from zip files to streaming music. If you'd like to learn more, check out these resources. Geeks for Greek for implementation in C, Wikipedia for theory, YouTube tutorials for visual learners. I encourage you to try building a Huffman tree on your own or use online visualizer like OpenDSL. Thank you for your attention. I hope this helped you understand how Huffman coding works and how it is implemented.